Hey guys, welcome to part 2 of my counting particles series. If you haven't seen part 1, I suggest you go watch that first. Today we're going to be talking about Avogadro's number and molar mass. Let's get into today's video. First, let's look at the problem from our last video. We know that copper-63 and copper-65 combine to get the atomic mass of copper. Copper-63 actually weighs 62.92 AMU, and it makes up 69.09% of all copper, so we multiply it by 0.6909. Then we add that to copper-65, which is actually 64.9278 AMU. And multiply that by 0.3091. Now, when we combine the values, we know that it's 43.4714 plus 20.0692. So, once we add those together, we get the atomic mass, which is 63.5404. Did you get it right? Okay, let's review for your English test next week. Are you ready?
Yeah.
What's it called when you have 2 of the same object?
A pair.
What about when you have 12 of the same object?
A dozen.
Okay, here's a hard one. What if you have 144 of the same object?
A growth.
Good. Now, this is the hardest one on the list. What do you call it when there's 6.022 times 10 to the 23rd atoms of an element?
I don't know.
It's called a mole. Just as saying you bought 2 dozen eggs instead of 24 eggs, scientists talk about atoms using certain familiar units. Since atoms are so small and therefore hard to observe singularly, you'll often see them talk about atoms in moles, which is equal to about 6.022 times 10 to the 23rd atoms. This number is called Avogadro's number. Yes, I know it sounds like avocado, so I'll give you a minute to laugh at that. Okay, let's talk about carbon-12 for a minute. If you remember from the last video, carbon-12 has an atomic mass of 12 AMU, or atomic mass units. This can also be referred to as the molar mass of carbon-12 in grams. That means 1 mole of carbon-12 weighs 12 grams. So, 6.022 times 10 to the 23rd atoms of carbon-12 weigh 12 grams. This is called the molar mass since its mass is based on the mole of that element. Let's try to find the mass of a single carbon-12 atom with the information we just learned. We know that the molar mass of carbon-12 is 12 grams. We know that there are 6.022 times 10 to the 23rd atoms of carbon-12 in 1 mole. So, if we take the molar mass, which is 12 grams, and divide it by 1 mole, or 6.022 times 10 to the 23rd atoms, we should get the mass of 1 atom of carbon-12. In this case, it's 1.993 times 10 to the negative 23rd grams. It's really small, but it makes sense, doesn't it? Now you try an example on your own. How many moles are in 6.46 grams of helium? I'll give you a hint. The molar mass of helium is about 4 grams. Think about the relationships between molar mass, moles, and Avogadro's number as you do this problem. Come back next week to get the answer. Let's review what we learned. Scientists like to measure things in familiar units, just as we do every day. For atoms, they tend to use moles. 1 mole is 6.022 times 10 to the 23rd atoms of an element. This is called Avogadro's number. On the periodic table, you'll see that there's a number. It's called the atomic mass. This can also be referred to as the molar mass because this is the mass of 1 mole of that element in grams. If you're still a bit confused, try out the mathematical example I showed with carbon-12. Then, try out the problem I gave after and write your answers in the comments below. Please like, share, comment, and subscribe for more videos every week.